Hey guys, welcome to my video. Happy Diwali, happy Diwali to everyone. And in my today's video, I'm going to discuss part 2 of non-negative integral solutions. If someone has missed the part 1, please go to my channel and watch it and stay with me till the end of this video also. And if you like, please subscribe to my channel. So without wasting much time, let's get into the topic. Before we learn how to find the positive and non-negative integral solution when there is a restriction at the lower end and also the upper end, we should be aware of what is the coefficient of x bar r in the expansion 1 minus x whole raised to minus n. So the expansion of 1 minus x whole raised to minus n is 1 plus nc1x n plus 1 c2 x square n plus 2 c3 x raised to 3. And if you continue this pattern and to write the x bar r coefficient, it is cr n plus r minus 1. So in case if we want to find out 1 minus x whole raised to minus 2, coefficient of x to the power of 10, it is x to the power of 10, c10, 9 plus 2, 11. So this expansion is very important to know before we learn this method of finding the non-negative integral solutions using this coefficient method. So let us see what is a coefficient method. So this method works when there is a restriction at the lower end and when there is a restriction at the upper end. Maybe I will continue with the same example what we have discussed in the earlier video. Let's say if I'm having x plus y is equal to 5. Now both x and y can take any value starting from 0 and till 5. So for each variable, we will be writing 1 plus x square till x raised to 5. This is for x, and for y, 1 plus x square. This is the method by which we will be able to collect the sum to be 5. When the bases are same, powers can be added. And in this, if I'm able to find the coefficient of x bar 5, I will be getting the required non-negative integral solutions. But this is also in GP. So we will be writing x bar 5 coefficient in 1 minus x bar 6 by 1 minus x whole square. So x bar 5 in 1 minus x bar 6 whole square into 1 minus x whole raised to minus 2. Since x bar 6 is higher than x bar 5, so we can neglect and take only 1. So now the problem reduces to x bar 5 in 1 minus x whole raised to minus 2. And to find the x bar 5 coefficient, we write C5 and then 4 plus 2, 6C5. This would give non-negative integral solutions. And suppose I want the positive integral solutions, then I have to write the expansion starting from x bar 1 to x bar 6 whole square and find the coefficient of x bar 5 in this. And this also leads to x square outside 1 minus x bar 6 by 1 minus x whole square. The number of terms are still 6 and I have taken x bar x square outside. Now as this problem reduces to as good as finding the coefficient of x cube in the remaining part, so since it has a higher power, we can neglect this term, and the coefficient of x raised to 3 in this expansion 1 minus x whole power minus 2 is C3 2 plus 2 4. So it's going to be 4. These are the positive integral solutions. So this is the straight application of finding the non-negative and positive integral solutions using the coefficient method. But let me tell you, when there is a restriction at the lower end and at the upper end, let's say 3 dice are thrown. Find the number of ways of getting some 15. So dice cannot start with 0. Dice has the numbers from 1 to 6. That means there is a restriction at the upper end as well as at the lower end. But according to the previous statement, we can write down the equation as x1 plus x2 plus x3 is equal to 5. But each xi here can lie between 1 to 6 only. So restriction at the upper end, restriction at the lower end. So this can be found using coefficient method. And the problem is to find out coefficient of x bar 15 in the expansion x bar 1, x bar 2 till x bar 6 whole cube. Whole cube is basically for each variable. Now, in order to find this coefficient, I can take out x common, but x cube will come out. And I have GP expansion of 1 minus x bar 6 by 1 minus x whole cube. Now, finding the coefficient of x bar 15 is now reduced to x bar 12 in 1 minus x whole power 6 whole cube into 1 minus x whole power minus 3. So since x6 is lesser than 12, so we need to take both the expansions here. And while we are taking both the expansions, we'll be writing 1 minus 3c1 x power 6 plus 3c2 x to the power of 12. After that, we don't need the terms into 1 minus x whole raised to minus 3. So now the coefficient of x bar 12 in this product. If I'm picking one, I have to take the coefficient of x bar 12 here, which is going to be 12, 14c12. Then when I'm considering 3c1, I already have x bar 6 here and I need to find the x bar 6 coefficient, which is 6c, 8c6, plus when I consider 3c2, I have to pick the first term. It's already x bar 12 here. I have to pick the constant term, which is 1. So when I calculate all this, it gives the answer as 10. So in this particular question, we had a restriction at the lower end and also the restriction at the upper end. Since dice cannot take any value starting from 1 to 15, it takes only values from 1 to 6. Here is another example. In how many ways can 3 persons A, B, C, each having 6 1 rupee coin, 7 1 rupee coin, 8 1 rupee coin can donate a sum of 10 1 rupee coin collectively? So this problem can be solved by using the equation x1 plus x2 plus x3 is equal to 10. And each xi, like x1 can lie between 0 and 6. x2 can lie between 1, 0 and 7. x3 can lie between 0 and 8. So with these kind of restrictions, what we can do is we can find out the coefficient of x bar 10 in the expansion of 1 plus x plus x square till x power 6, 1 plus x square till x power 7, and 1 plus x square till x power 8. So when we actually take up the GP summation here, it's going to be 1 minus x power 7, 1 minus x power 8, 1 minus x power 9. Into 1 minus x whole raised to minus 3. Finding the coefficient of x power 10 in this. 1 minus x power 7 minus x power 8 minus x power 9, neglecting the higher powers, we will be having this as a final expression. So in this, if we collect the coefficient, like if I'm taking 1, what is the coefficient of x power 10 here? That will be 12c10 minus, if I'm considering x power 7, I'll have to collect the coefficient of x power 3 here. That would be 5c3. Then minus 1, if I consider for x power 8, I have to collect the coefficient of x power 2 here, which is c2 and 4 here, minus 3c1. So overall, if we calculate this, it's going to be 47. So this is where the coefficient method is used when there is a restriction at the upper end. Simultaneously, you can also when there is a restriction at the lower end also. Hope this explanation is clear to everyone. So we'll come up with more concepts in the next video. Bye for now.